Okay, I'm not sure for those online, can you see this? The line, because the marker is not that.
Yes, sir.
Yes, sir, we can see.
Alright. Now, the issue is not the issue. Now, when we talk about f prime, actually it's not compulsory to find f prime. For f prime, we use when we want to calculate step by step the two triangles, right? So let's say we have this axis, and then we have a certain so hopefully you can still now, what is important is that whenever you have a force, let's say you have a force like this, the important thing is just to have, in terms of Cartesian vector, right? So F equal to F x I plus F y g plus F z t. That's the important thing. As long as you can find the component, x component, y component, z component, no problem, right? So in some cases, for example, alpha, beta, gamma, so straight away you use the equation to find. But when you have two triangles, right, meaning that it is projected in such a way that let's say you have two triangles. One triangle is we consider this big triangle, for example, where this is the right angle, and let's use a different color. Another triangle is, let's say, this one, where this is the right angle. Right? Now, if you use, okay, let's say we have two angles. Let's say this is 45 degrees, and let's say this is 60 degrees. Right? Now, for me, that because I've dealt with this a lot, I do not need to find f prime because I can calculate straight away. For example, fx is from here. I know fx is basically f sine 45 degrees cos 60 degrees I, and then plus, okay, this is x, y, z, right? So plus f sine 45 degrees sine 60 degrees j plus f cos 45 degrees k. Right, so anyone, can you see, right? So anyone who can do this, no problem, right? But if you just recently, have the exercise of dealing with these two triangles, that's why you do step by step and you label this f prime, right? So that from here you know f prime is f sine 45 degrees, and when we deal with this triangle, so this x component is f prime cos 60, or f, you take this one, f sine 45 145 cos 60. So for those who have done this exercise a lot, they can do the two-step or two triangle in their mind and they straight away get this one, right? So now back to your question. When we talk about in the problem group problem solving, you have two forces. One force you have these two triangle. Another force you have the alpha, beta, and gamma. For example, we have, let's say, another force, and then you have alpha, beta, and gamma. So alpha, beta, and gamma, because the purpose is just to get x, y, and z. So your purpose is not to calculate a lot of things. Your purpose is just to get this one, right? So alpha, beta, and gamma, you can straight away use the what what is fx? F cos alpha, right? So fy, f cos beta, f z, f cos gamma. So you just straight away use the value, plug in, and then you get the Cartesian vector already. So back to the question, f prime is just a mathematical step that you do, which is not compulsory. It's just to help to do step by step if you cannot imagine how to get it straight away like this yet. Does that answer the question? Alright. So this is my assumption of what you mean, but please do clarify what exactly you mean. When we have Cartesian vector form of something I, well, then when we talk about positive and negative, right? Something I, and then something j, and then something k. So it is possible to have positive, 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 or to have negative or whatever, right? So this depends on the direction of the force. So meaning that in 2D, if this is at positive x-axis, so if the component of the force is here is positive x, if it's the opposite is negative x. So that's just how it is. So when you have x, y, z, normally any force that you have, just for example, if you have a force here, so if you project it, so if you project it down here, it will be something like, for example, so in this case, and then equal it to z, oh sorry, okay. So in this case, the component is something like this. So you have x component, y component, and z component, right? So in this case, you can see that x component is positive, y component is negative, because positive is here, so negative, and z component positive. If you have another force here, for example, so if it is something like that, meaning that the x component is still positive or here, y component is positive, but z component going down is negative, right? Something here. So that's the primary understanding that you should have, meaning that the component positive and negative is depend on whether they are it is in the direction of x positive, y positive, or z negative positive, or the other way around. Now, so now we have three ways of getting Cartesian vector form, right? One is just by the two triangles, let's say. Second is by alpha, beta, and gamma. The third is by coordinate, and then you calculate r, you calculate u, and then you calculate further, right? Can you still see this? Okay. Now, if you do, okay, if you use the two triangle, right? Let's say, let's say we have this is x, y, z, but I prolong this x on the negative side. So let's say our force is somewhere here. Where to be projected here? Let's see. let's say something like this, meaning that it's on that side, right? So in calculation, to get the magnitude of x, y, z component, you will use the triangle, right? You will use if you have this one, for example, you have one triangle here, another triangle here, right? Then you get the value. But you should be able to tell that, okay, in this case, x is negative, right? Because positive x is here, so x is negative, so it will be negative here, I. And y is positive here, because it's the direction positive, so positive. J and z, of course, if going up is positive. Right, so that's the nature of this one. You should be able to tell by looking at the diagram. Because the triangle just gives you the value, the magnitude. Positive or negative, you should be able to tell by the diagram. If you use alpha, beta, and gamma, because by definition of alpha, beta, and gamma, let's say I have here, right? So alpha is by definition the angle it makes with x-axis, positive x-axis. So alpha is this one, right? If the force is on the back here, right, and you have x-axis, meaning this is positive x, this is negative x, alpha is still with the positive x, not this one, right? So with that, when you have cos alpha or cos beta or cos gamma, when it is less than 90 degrees, you get positive, right? When you get more than 90 degrees, meaning 100 something degrees, etc., you get negative. So it automatically gives you positive or negative based on the angle. Meaning for this one, for example, is 60, you plug in f cos 60, you get something positive. This is, for example, 120, for example, you get f cos 120, you get negative automatically. So for alpha, beta, and gamma, positive and negative automatically come based on the angle. Do not add another negative there, because it will be, for example, negative become positive, which is wrong. So that's the nature of alpha, beta, gamma, right? So when the angle is on the negative side, for example, if something like this, gamma small is upwards, right? When it goes downwards, gamma is already beyond 90 degrees, so it's automatically become negative, right? So that's an example. That is alpha, beta, and gamma. For coordinate position vector and unit vector, because when you calculate the position vector, it's already when something minus something, because if the force is something like this, and this is point A, this is point B, for example, right? And then when you calculate R, A, B, is basically coordinate B minus coordinate A, right? So if it's going down, obviously the Z component is already negative, because negative coordinate minus the positive one. So if you use coordinate R and U and so on, unit vector, positive and negative will automatically be in there as well, because it is based on the coordinate, right? So if you use alpha, beta, gamma, or if you use coordinate position vector, unit vector, just follow the process. Positive or negative will automatically be in the answer. But for the two triangle will only give you the magnitude. You have to know from the diagram, looking at the diagram, okay, this is positive, this is negative, etc. Right? So that's how it is. Is that the question? So if that is the question, that's the three things that you have to understand.